Greetings everyone, I am Devansh Gupta from Midas Lab at Indraprasth Institute of Information Technology, Delhi, and today I'll be giving a presentation of our work, a suspect identification framework using contrastive relevance feedback, which is accepted in this year's evacuation proceedings in the application track. Our method attempts to solve the problem of iterative feedback driven image retrieval based on the user's visual memory. Essentially, based on some initial attributes provided by the user, our system presents some images to the user. Based on the images selected by the user as similar in that iteration, our method suggests a new set of images based on the feedback from previous iterations. This continues until the user finds an image that he or she is satisfied with. For example, you can see a demonstration of an ideal case on the slide where the user's visual memory is depicted on the left, and then based on the similarity suggestions denoted by the green ticks, the system progressively recommends new images until the most matching image is found. Solving this problem shows great potential for tasks in which humans can repeatedly interact with the system to retrieve certain facial images. For instance, with visual memory, we can automate and accelerate the process of suspect identification or missing person identification, turning out to be very useful in time-sensitive matters. In fact, any kind of identification by a person which is useful for criminal investigations can leverage the system very well. Moreover, since there is only a single form of feedback, it imposes a less cognitive load on the user. Previous approaches like Rocchio on image representations and face fetch have attempted to solve this problem and have shown good results. However, they suffer from certain disadvantages. The Rocchio algorithm is very fast and simple, but it is a fixed algorithm that doesn't account for user personalization at the embedding level. The face fetch curbs the problems proposed by the Rocchio algorithm and attempts to personalize the embeddings by defining an auxiliary classification task on the selected and the non-selected images by the user at each iteration, and uses those personalized embeddings to run the Rocchio on the system. However, this does not guarantee separation in the latent space, making the metrics inconsistent in computing the query vector across iterations. Our proposed approach further improves upon face fetch to impose consistency of learned embeddings over iterations by reformulating the approach as a contrastive learning problem. Since feedback is provided in a binary fashion, we can simply cluster together the selected images close to each other and make sure that all remaining images are away from each of the selected image. We propose a separating cluster loss which characterizes this kind of divergence in terms of loss functions in a different representation space that can be optimized online. Since we are making changes at the embedding level in the form of clusters, we can simply score the remaining images based on the distance from the center of the cluster in that representation space. Here, we can see a visualization of our proposed approach. Note that we use disentangled representations for a system. We used them because we felt that these representations are interpretable and highly effective in downstream tasks. We use the disentanglement mixing approach to generate our representations. For assessing our method, we designed a user simulator which computes a rough estimate of similarity using average of cosine similarity of different representations. We assess our models by the average convergent iterations and the average relevance of images on celeb A and our criminal dataset provided to us by the Metropolitan Police Department. We can see that at an average, our model consistently performs better than the baselines. To compare against the baselines in a practical setting, we conducted a large-scale user study on different datasets where we obtained the following cumulative results based on the responses given by the users after interacting with the system. We also show the best trends that we obtained from our user study. The work was funded by the Metropolitan Police Department for faster retrieval of suspects to aid criminal investigations. For that, we designed a user-friendly web interface that efficiently takes in user feedback and displays the next set of images in a convenient manner. Our attribute selection page for the initial set of iterations can be seen on the left image and the image display can be seen on the right. Thank you for listening to our presentation.